Bismillahirrahmanirrahim. My name is Muhammad Shoaib. Welcome back. Today in this video tutorial, we will learn what is a function block or FBs in the Semantic Manager and how to configure the function block in Semantic Manager. Whether you are the beginner or just looking to refresh your skills, this guide will help you to get started step by step. So, what is the FB? In the Semantic Manager, a function block or FB is a reusable block of code that retain memory between the execution. FBs are ideal for programming logic that need to store data such as counter, motor, and the PID loops. Unlike the functions or FC, which are stateless, FB maintain their internal state using the instance data block or IDBs, allow them to remember value between the PLC execution cycle. So some of the FB's characteristic like the memory retention. FB store data across cycle with the help of instance data blocks or IDBs. For example, a motor control feedback. Remember whether it was running or stopped between the PLC scans. In encapsulation, FB's encapsulation, you can encapsulate complex logic within the FB function blocks and call in the multiple time with different instance data like different for the different motor. We will in the in this same tutorial video we will call same we will develop one FB block and then we will call it for the multiple motors. So we'll practically will also see shortly. Then reusability. FP can also reuse throughout your project with each instance behavior independently using its own IDBs. So when we will call motor 1 and motor 2 FPs, the both FPs will work independently and their instance that DB will also be work independently. Then the FB's input and output parameters. FB can accept input and provide a output and make them flexible and modular for various control tasks. When you can use a FB block. So when you need to retain state information between a PLC cycle, when developing repetitive logic such as controlling multiple motors or valves where each one has unique setting or states, or for the PID controllers where the algorithm need to remember previous values like integer term to maintain the proper control. So structure of the FB. The structure of FB like consists of the input parameters. These input parameter values pass into the FPs like the motor start and stop command. We will shortly see how we can configure the input parameter of the FB. Then we have the output parameters. Value returned from the FB like the motor status, motor should run or stop. Then the static variables. This static variable store inside the FB and retain their values between the cycle. Like for example, we will use in this tutorial like the motor runtime, like motor runtime timers value. We will store it and we'll see, and this value will retain, and like even the that in all of the cycle in the PLC cycle, the value will retain. We'll see shortly. Then the temporary variable use only within a single execution for the FB and do not retain the value. Okay, like this temporary variable will not retain the value, and we are using usually for the calculation purpose, like immediate calculation some of the values in the one cycle. We have to reuse it. For those purposes we are just using. Then how FP work with the instance data block. The instance DBs or IDBs store the internal variable of an FP for a specific instance. For example, if you create a FB for the motor control and use it for the motor 1 and motor 2, each motor will have separate IDBs, instance data block, that store its individual states like motor run status, current, speed, runtime, those all things. So before create a new project, we also have to understand how the FB will work. So in the previous tutorial, we already learned how OB1 will work. OB1 is executing logic cyclic. So we already learned like OB1 will take the input data, and after that it execute the logic, and once the logic in OB is execute, and after that it's update the output, and this cycle is again start. So like cyclically OB1 always continue work. So we call FBs usually in the OBs. So as you can see in this image, like FB1 is called. So in the execution cycle, once the FB1 is called, so it execute the FB1 logic, and whatever the statement or rungs is execute, and after that the it will go back again, and then the so on next all FBs, whatever the FBs in the OB, those step by step, like you can see FB2 is there. So once the FB1 is execute, and then the FB2 is execute, and once it will also return, then the it will update the OB1 will update the whatever the status, it will update in output status. So like that this work. Okay, so let's see how we can develop a project. So we'll create a new project. To create a new project, click here in the semantic manager. Okay, we'll select, click at next, select any of the controller, whichever controller you want to select it, and then click at next, and we'll select the ladder language, and then click at next, and we'll put the project name. Suppose I will put the project name, project, and FP1 project FP. Okay, then click at the finish. So our project is successfully created. So uh, we'll assign, we'll come here and click at double click over the hardware, and we'll add some input and output module in our project. Okay, so just expand semantic 300, and we will assign us some interface module. So after assigning the interface module, then come here and we'll assign an input module. For example, I will take randomly any of them, and we'll take the some output module also. Okay, so Uma should have to know what is the input address for this. Right click and edit symbol. Okay, so as you can see our input address starting from the I0.0. You can see it from here also. And similar manner our output address, right click, edit symbol. So you can see our output starting address is 4Q 4.0. Okay. After that, just click here, save and compile. Okay. One more setting we have to do. Come here in the CPU, right click and object property and cyclic block memory, and here just put 100. Later I will tell you why I enable this option. Okay. Just save and compile. So it's successfully just close it. Then come here in the blocks. Now we'll create a right click over in this area. Okay, and then come in the new insert object and then select the function block. Now we are going to create a function block. Okay, so I will create a function block, right? Like I will put the name is motor. Okay, and I will select the ladder language, and that's it, and just click OK. Okay, now double click over this FB. So the FB is open now, and I will develop some logic. I will select the NO, then NC and output contact, and I will just create a one logic, one latch logic for my pumps. Okay, so here I have to assign the input. To assign the input, first I have to configure my interface input. Okay, so here I will put like start command, press enter, then stop command, press enter, then reset my runtime, timer. Okay, reset time. Okay, and then for the output, here I will configure like motor run, and here I will also put like the timer. Okay, timer pulse. Okay, okay, and after that I will come here in the state. I know this will retain the value, so here I will put the runtime. Um, Run timer. Okay, and I will select, for example, this for the word. Okay, so you can select any of the data type, up to you. Okay, now this logic that I developed, I will assign. Suppose I want first the start, so I will select the start, and then this should be NOC for the stop command, and this is for my motor running, and here I will also use the same motor running. Okay, this is just I developed logic for to control my motor. Now I'll add a new run and insert a new network. And I want, once the my motor is running, that time I want to run one timer also. So for that, I just want to calculate how many seconds my pump is running. You can put, you can use like second or minutes or hours, any type of timer. So I'm using here, instead of timer, uh, the by default cyclic pulse. This will give me M1. That's why I configure in the memory clock there. So M100.5 give me 1 second pulse. Okay. And here I will configure this. I need it. So this I will configure it here. Same, the timer pulse. Okay. So now, once my time motor is running, and this will give me the pulses whenever the my motor is running. So I will insert a one new, and I will select the no contact, and I will use this timer pulse, and I will take a one counter to calculate for how many seconds my timer is my motor is running, for how many seconds. So here, I will put my runtime timer value. Okay, and here the timer reset. So if I want to reset my counter, so I can press this one, and this is for the calculate the time, how many for how many time it's running. Okay, so that's it. Just save it. Yes. So yes, I will close it. Okay, now open the OB1 as I explained in one block diagram. We will call this FB1 inside the OB1, because the why I will do it, because the OB1 will only execute cyclically. So we'll call it. So at each PLC scan cycle, then from the OB1, FB1 will call. Okay, to bring or call FB1 inside the OB1, okay, organization block, function block to call. So you have to left side in this, in left side menu, you have to just expand FB1 block. Then you have to select the FB1 motor. Just select and drag and drop it here. So first thing that you have to assign a instance DB name. So for example, I will put DB10. You can put it anything. So it's saying that the instance data block OB10 does not exist. Do you want to generate? Yes, I want to. So it will automatically generate, and here you will get the instance DB data block. You can see its name is instance data block. Okay, now I will start to assign my input. For example, if I will put I 0.0 for start, and I 0.1 for stop, and I 0.2 for reset timer. And for the motor run, as in beginning I explained, it will be Q0 4.0, and for the timer also I will put Q 4.1. Okay, so this is for my m- motor 1. Okay, that's it. Just save it. So we'll download this program and we'll run it. So I developed this for the one motor logic. So I will just close it and I will click here to turn on my PLC sim. Okay, then the first step here you have to select the MPI interface because I'm using SM300 and they don't have the TCP/IP protocol. So I will use the MPI interface and then click here in the run, and after that select and download the program. Click here. Okay. Okay. Do you want to start? Yeah. So you can see now our PLC sim in the running state. So I will open my OB1. So our OB1 is open now, and click here to go in the monitor mode. So you can see right now we are in the monitor online mode. So if I will turn on the input, so as you can see my output is also on, and I'm also getting the pulse of the 1 second that I already configured. So if I want to open the my function block, what logic is executing. So how I can open it? Right click here, call a block and select the open. So click here to go in the online mode or monitor mode. So as you can see, as it's have their own memory. So if I will even stop it, so you can see it will, I will stop the motor now. So my timer is runtime timer is stop now. Okay, so here you can see runtime, how your logic is working. So as you can see, this timer is working now. So I will close it now and I will open again OB1. Okay. So OB1 is open now. Now this is for my motor 1. I will insert a new network and then I will again call this block for the motor 2. And right in this time I will put DB11. Okay. So DB11 is not there. So we will generate it. Click yes. And for this, I will put input address I0.3 and I0.4 and I0.5. And similar manners, the output will be Q4.2 and the Q4.3. That's it. Fine. Just save it and click over the download button. Click yes. But better, because then we have to download this DB also. Better I will download the complete program. You can select just only the DB is newly created. Okay, click yes. Okay, our PLC in the run mode. So I will click here in the monitor mode or the online mode. Okay, so I will just start my second pump. So as you can see, now my second pump is running. If I want to just start my first pump, so my first pump also running. So as you can see it here, I develop a one function block. Now I'm reusing for the two different motors, for the motor 1 also and the for motor 2 also. Okay, so Alhamdulillah, we learn what is a function block or FB, and then we also learn how we can configure the FB inside the semantic manager, and we will also learn how we can create a one FB block and how we can use for the multiple uh, instance, okay, for multiple motors. So thanks for watching this video.